Hello everyone. Sorry about canceling the class today. Instead, we will do our lesson 3 in the following videos. So please watch the probably 3 videos, maybe 3 to 4 videos, and we will come back to the classroom next week and discuss any question you may have. All right, so here is lesson number 3. Okay, so you can, lesson number 3 is about moment. You can read the notes here. Moment, force can, a force can move a body or an object, and it can also tend to rotate a body about an axis. And this rotational tendency is known what we call moment, and we will be using M to indicate it's a moment in this lesson. Moment about a point. For 2D force, it's in plane, right? Because it's only plane, 2D is a plane. And moment depends on the magnitude of the force and also what we call a moment arm. Moment arm. So not only the magnitude of the force matters, the location of the force is also important. And that moment arm is perpendicular distance from the point of rotational axis, in other words, point of interest, and the line of force actions. And we will see what this means. For example, if we have a body, a rigid body, any rigid body, right? And the, say, point A is the point of interest. So now the force can be, let's say we have a force applying at this point. What is moment arm? Well, the perpendicular distance from the point of rotational axis, which is point 8 in this case, and the line of force actions. So let's draw a line, the line of force actions, the line of actions. And it's the perpendicular distance. In other words, here is 90 degree, right? Here's 90 degree, right here, 90 degree. And it's this distance what we call D. That's the moment arm, right? That's the moment arm. And then the magnitude of the moment is simply M equal to dF. All right, so now which way is this? Using the right hand rules, right? Using the right hand rules. So if my hand, if my hand and pointing to the force wrap around the axis, my fingers into the page. Try that, into the page. In other words, it's counterclockwise. Right, it's counterclockwise. Now, moment sign conventions. What would be the conventions? It depends on how we define the directions, right? So if into the page is into the page is let's say into the page is negative. Sorry, That's right. Into the page is negative, and out of the page is positive. So let's write it out. This is y, this is x-axis. Where's the positive z-axis? Well, if we wrap around, pointing to x, wrap, and then point to the y. Now my finger is actually out of the plane. For you, it looks like you are into the plane. Okay. Because we're doing these videos, everything is mirrored, so you have to be careful. Just try yourself, right? Your finger is pointing to x, and then wrap towards the y. And if you do that, following my direction, you will find your thumb is pointing out of the plane, which I should point to the opposite direction, so you feel like I'm pointing out of the plane. Okay, and that is positive. All right, and the other direction will be negative. When we solve the problem, as long as we are consistent, it should be okay. Okay, it should be okay. Cross product. Oh, unit. Don't forget about a unit. What would be the unit? If it's force times distance, the moment arm is the distance. So the unit would be, let's write it out. Moment is force times distance, and therefore it's we are probably more familiar with Newton times meters. Okay, can be inch pound too, pound inch, or pound feet, depends. Now do not say this is equal to joules. We don't do that here, because this indicates we are working with moment, not energy. Big difference. Even though they have the same Newton times meter unit. All right. Cross product. So cross products in many problems, right? Many problems, especially 3D, it's more convenient to use vector analysis for moment calculations. For 2D, it's not too bad. 3D, it's easier, much easier to use vector analysis. Okay. Now, the moment of the F force about point A may be represented by, let's write this. So this is F. Okay. And now this, the moment, it says the moment of F about point A. So let's write, equal to the moment arm cross the force vector. Where is that R? Well, if you go from point A, because that's the point of interest, to the point where F is applied, that is your position vector, right? Position vector R. Okay, position vector R. Good. So moment vector Now you can see what is the direction. R cross F. So try that. R cross F. Again, my image is mirrored. So be careful. So try yourself. I don't want to confuse you anymore. So this is the force vector. Okay, and this is the position vector. All right. Now, what if we want the magnitude? If I go back up, right, the perpendicular distance from the point of rotational axis and the force line of action. So now it's drawn here. To save time, I will draw right here. This here is 90 degree. So the moment arm, and let's use maybe use another color here. The moment arm is this D, right? D. Yep. So in 2D, the magnitude of the moment is simply equal to, you can write FR sine and where the angle, okay, oops, sorry. FR sine alpha equal to simply F times D. So where's alpha? Let's write it out. It's going to be the angle between R and F. So here's alpha. Okay, between R and F. Now, the moment of a force about any point is equal to the sum of the moment of the component of the force. Very, very difficult to say. Anyway, so again, the moment of a force about any point is equal to the sum of the moment of the component of the force about the same point. What does this mean? Instead of reading this, let's try to understand this geometrically. Okay, so let me draw this first. So this is you have a force, say a force vector R. So here we use R. Okay, and point O is right here. You can see the point O is right there, right? Now if we draw a line, that's the line of action, right? Line of action. Then the perpendicular distance, right here, and this is 90 degree. This would be our D. Okay, our D distance. And the position vector R, I will use this color, position vector R. From point O to the where the force is applied, and that's called that I have it me here, B, point B. All right. So this R here, you can see it's now separate into two vectors, P and Q. P and Q. Right? So R is equivalent, is P plus Q, really. It's just what it's saying. The sum and the moment of this R force, R vector, is equal to the moment of P plus the moment of Q. This is what it's saying. Okay, so let's write it out. Moment, and moment has a direction, don't forget. Let's check, we have to check the direction as well. Moment about point O is equal to R cross the big R. Position vector cross the force vector. And if, let's say, if R is equal to, well, not if, R is equal to vector P force and then another vector Q force. So in that case, we can replace this R here. Right? We can replace this R with P and Q. So how do we do that? Let's check. Then R cross P, sorry, R cross R. R cross R is equal to, I'm going to be careful here, R cross R is now replaced by P and Q. Okay, P and Q. P and Q. Okay. And the distributive law for the cross product, we can do that, and that equals to, okay, equals to R cross P plus R cross Q. So mathematically, this is what the sentence here is saying. Okay. So if D is more difficult, let's read here. If D is more difficult to determine than P and Q, then we can resolve R into P and Q. Right? For convenience, based on the theorem above. So we have vector P, Q, both of which combined will give us vector R. That's what it means, right? And the origin point O right here. And now, what does this mean? If D is more difficult to determine than P and Q, we can resolve R into P and Q. That little P and Q, this is what it is. Let me show you. So let's draw the line of action for vector R, the R force. Similarly, if we do that for the P force and the Q. Okay. So D is the distance, the perpendicular distance from the origin to the line of action. This is 90 degrees. That's our D. P, the same perpendicular distance. If this is 90 degrees, then this is our little p. And q, now it's a bit right here, so let me draw right here. This is q, and let me maybe clean up a little bit here. Let's put the d on this side here. That's d. Okay, are you able to see that? D is the perpendicular distance between the point and the line of action, R. P, right here, that's the perpendicular distance from O to this line. Similarly for Q, if you draw this, and this is 90 degrees here, then this is the little q is the distance from O to Q. So now we can write MO, the moment about point O, equal to RD, and that is also equal to P and P and Q and Q. Now, is P positive? Is this moment here positive or negative? If we look at P and now wrap around point O, right? Do it that yourself, you will find it's negative. Okay, so in this case, I say into the page is positive. Aha, that's why I got confused. So here I'm saying into the page is positive. So in this case, P will be negative. Q, let's check, will be positive. And be careful, if into the page is positive. Okay, here we are saying into the positive is positive. So P, the moment due to P will be negative, the moment due to Q will be positive.